base class is for transmitter. For process control loop, the basic units are the process variable is to be measured by measuring instrument, and then the measured signal is to be transmitted to the controller or comparator, where the set value or the desired value is compared with the measured value. Rather, the measured value is compared with the desired signal, and if there exists any deviation, then the controller will take the corrective action. Accordingly, the control action will send to the final control element to adjust the energy input to the process. That is the fundamentals of process control loop in feedback process, since mostly the control loops are feedback control system. Now there is a major important role of a device called transmitter, which transmits signal from process to the controller, and the control action signal is again sent to the final control element so that the energy adjustment can be done. So this transmitter basically transmits the signal from the measuring unit to the receiver end. So there are depending on type of energy, like all other devices like controller, control valve. So depending on type of energy operation, that means pneumatic type, electrical type and electronic type. That is, signal is pneumatic signal, that means pressure operated signal, or electric signal, current or voltage operated, and if the operating devices are electronic type, then that is electronic. So depending on type of energy operation, pneumatic type transmitter, electrical type transmitter and electronic type transmitter exists. For pneumatic transmitter, there is a flapper nozzle system and pneumatic amplifier or relay. Like all other pneumatic devices, the basic units are flapper nozzle unit and pneumatic relay. The transducing signal from the measuring device is sent to the flapper unit so that the displacement of flapper nozzle can be changed, and accordingly the nozzle feedback pressure changes, that is the controller output, or that is for this case that is the transmitter output, and that sends to the pneumatic relay. Since the signal is very low, in order to amplify this, there is a pneumatic relay, and the sent signal to the receiver end is the pneumatic signal of 0.2 to 1 kg per centimeter square, or 3 to 15 psi. And there are two types. Here there is a receiver called receiver gauge at the receiver end, like this. So the receiver gauge means where it is written as receiver gauge typically of the range of 0.2 to 1 kg per centimeter square, or 3 to 15 psi. But for pressure gauge, where it is written as pressure gauge, that pressure gauge may be of any range. But receiver gauge means typically for the range of 0.2 to 1 kg per centimeter square, or 3 to 15 psi. For electrical type transmitter, again detector and this transducer is electrical type transducer. Then there is a transmitting potentiometric circuit, like say for a level control system, say for a tank unit, if the level changes, there is a certain level, and say there is a float for measuring the level. Then if the level changes, accordingly the float position will change, and that will connected as a potentiometer circuit. So the electrical output from this potentiometer, so as this position will change, then this potentiometric output will change accordingly, and the current signal or voltage signal, whatever we normally the signal transmission occurs in terms of current signal. So the measured electrical parameter will change. For electrical type transmitter, there exists a transmitting pot in order to transmit the signal. Again, the current signal is typically of 4 to 20 milliampere range. And for electronic type transmitter, that is one stage advancement over electrical type transmitter. Just like the signal is again electrical signal, but there is a pre-amplifier and then amplifier or filter rectifier circuit, whatever needed, and all these are voltage devices. So before transmission, the voltage to current conversion is required, and then it is sent to the receiver end through the transmission line. There exist these are the transmission line. So there exists transmission line. So this is electronic type, this is electrical type, and this is pneumatic type. Now for this there is an additional unit called pre-amplifier. So what is the purpose of pre-amplifier, or this is called instrumentation amplifier? What is the purpose of instrumentation amplifier or pre-amplifier? This is generally high input impedance and low output impedance in order to avoid the error of loading. Since this is high input impedance and low output impedance, so this can remove the error due to loading effect. And another function of preamplifier is the function of impedance converter. That is, it converts high input impedance to low output impedance, so that low impedance devices like filter, rectifier, amplifier, whatever, so low output impedance can be connected at the other side. So this is the purpose of pre-amplifier. And then amplifier for signal amplification and for noise reduction. Pre-amplifier also, since this is instrumentation amplifier, so this is used to minimize the noise due to its differential input. As you all know that instrumentation amplifier has a differential input in order to reduce noise effect. Then so this is the basic block diagram of electronic type transmitter. Now pneumatic transmitters, basically pneumatic transmitters all are using flapper nozzle unit and pneumatic relay, and the other part is the sensing part. Say for this is a pneumatic pressure transmitter. See how this works. This is the enclosed chamber where this is the mercury, within this mercury tube is there, or this may be silicon, since it has high viscosity and compressibility. So this may be the silicon filled chamber, and this is the jacketed pipe through which this is connected with the DP cell. DP cell is the differential pressure transmitter, where there is a high pressure side and low pressure side. This is called the primary unit of transmitter, and the secondary unit is the flapper nozzle and relay system. So primary transmitting unit is DP cell, where the differential pressure compares and accordingly it changes the movement of flapper unit. See how this can be done. Since this is silicon filled jacketed pipe, if the pressure of this chamber increases, then the pressure on this will increase and pressure will rise at this side. This is these two are separated by two diaphragms. This is high pressure side and this is low pressure side. This low pressure side is open to atmosphere. That means when the pressure at this side will increase, that will increase compares with the atmospheric pressure. So pressure increase to the high pressure side means the pressure at this end, the pressure acts towards right. So this end will move towards right, and the motion beam is supported by some pivot, and that with respect to this pivot, the upper portion will try to move leftward. As a result, the flapper will move towards nozzle direction, so nozzle feedback pressure will rise, and that will, so the relay pressure, this is the amplifier, so the output pressure P0, when the input pressure P increases, the output pressure will also increase. Again, that depends on the use of relay type, whether this is direct action or reverse action type. So this is the function of pneumatic pressure transmitter. Primary unit is a DP cell and secondary transmitting unit is the flapper nozzle and relay unit. Next is pneumatic level transmitter. All these pneumatic transmitters, the basic unit is flapper nozzle and relay unit. This is like potentiometric system. Say in a tank there is a float. If the level changes, say if level goes downward, then what will happen? The weight of the float will increase, so this will move downward. With respect to pulley, since this is pivoted at this point, so this side, just consider this string supported at this point, so as this will move downward, this edge will try to move upward. Again, this beam is supported or pivoted at this point, so as this will move upward, this edge will move downward. That means that will move away from the nozzle direction, so the nozzle feedback pressure will decrease. As a result, the output pressure will decrease. Now what happens? When level decreases, the output pressure also decreases. Again, considering this is direct action type. Since we are trying to transmit the process variable, so when this is decreasing, the process variable decreases, corresponding output signal also decreases. So this should be chosen as direct action type. Like the last one, for pressure transmitter also, when pressure increases, the output pressure also increases. So this should be chosen as a direct action type relay. Next is pneumatic temperature transmitter. So for all temperature measurement system, this is called thermo oil, where the thermometer should be embedded. Say this is a furnace and this is the thermo oil where the thermometer can be embedded. Say mercury filled pipe and again jacketed pipe. Normally this is stainless steel made of jacketed pipe. So when temperature increases, the mercury pressure will increase at the lower portion of this chamber. This is separated by a diaphragm. So the upward pressure on the diaphragm will increase when temperature increases. Then as this will move upward, then this beam, which acts as a pivot, which acts as a flapper towards a nozzle element, this side will move upward direction. With respect to pivot, the other side will try to move at downward direction. That means flapper moves away from the nozzle direction. That means nozzle feedback pressure will decrease. Now for this case, what is happening, that when temperature increases, the pressure, output pressure decreases. So in order to maintain the proportionate signal, this relay should be chosen as reverse action type. Since for the previous two type of transmitters, when the process variable increases, the output pressure signal also increases. But for this case, when the process variable increases, the output signal decreases. So relay should be chosen as reverse action type, so that the proportionate action, that means when process variable increases, accordingly the output signal can be proportionately changed. And finally, the flow transmitter. Again, similar principle. Primary unit is a DP cell and secondary unit is a flapper nozzle unit. The flow through the orifice is tapped at the upside and upstream and downstream, and the pressure is measured, compared with upstream and downstream, high pressure and low pressure side. Like the previous example, where the low pressure side was open to atmosphere and the change of pressure is compared with the atmospheric pressure. Here the upstream and downstream pressure difference is connected across the DP cell, and with reference to the change, the flapper will move accordingly, and you just check the when the signal changes. That means what type of relay should be used, whether it is direct action type or reverse action type. This is additional unit for this level control system, and this is the standard unit called manifold, having 5 valve unit, where this valve is called equalizer. In order to maintain the DP cell, that means since there is a no open to atmosphere condition, so initially these two pressure should be equal. In order to maintain the upstream and downstream pressure equal, just open the equalizer, and so that this high pressure low pressure should be balanced. And during measurement, this should be closed, and all these 4 valves should remain open for the entire time. This is called manifold, a single unit of 5 valves. This is the real process manual from a certain plant. That this is the valve and the boiler drum. This is the three valve type manifold. Equalizer is there, and the high pressure side, this is the DP cell. High pressure side, low pressure side is connected. Exactly the similar type of operation. This is the detailed plant diagram. Next is advanced level advanced level transmitters. Those are electronic and programmable type. all these are programmable type, and first level was microprocessor based. For microprocessor based system, this is there is a sensor, then A to D converter, in order to digitalize the signal, then microprocessor, and again digital to analog converter, and then again the voltage to current converter is required for signal transmission. And this is the arrangement of primary sensor along with secondary sensor. This is for compensation. What is compensation? That means the effect of other parameter change that can be detected. So all programmable, this is the first level programmable controller, microprocessor based, and nowadays all these are programmable transmitters and called smart transmitter. What is the smart features? Transmitter in which the corrections are applied to the primary sensing signal, that is the primary sensing signal using a microprocessor to process information which is embedded in the memory, or those in which a microprocessor is used in conjunction with a secondary sensor to derive the corrections of the primary sensor signal, are termed as smart transmitter. So this is the basic block diagram for smart transmitter, where the corrections are applied to the primary sensing signal. That means this is for to check the healthy condition of the transmitter itself. This is the use of secondary sensor. Transmitter in which the corrections are applied to the primary sensing signal using a microprocessor to process information which is embedded in memory, or those in which a microprocessor is used in conjunction with the secondary sensor to derive the corrections for the primary sensing signal, are termed as smart transmitter. So this is the basic block diagram of smart transmitter. And what are the smart features? Smart features are linearization, characterization, and correction of primary sensor characteristics. How this primary sensor characteristics can be corrected, we will analyze the detailed structural description of smart transmitter. But the features are linearization, characterization, and correction of the primary sensor characteristics. Inclusion of control function and algorithms, other algorithms. Two-way communication between control room and plant, bidirectional, and storing information regarding location, serial number, range. That means data can be logged. These are the smart features. And intelligent features are adjustment of span and zero. One thing I forgot to mention, that span and zero adjustment, and adjustment of damping time constant or response time, and diagnostic or status checking. That is the purpose of using secondary sensor, that is diagnostic check or checking of the healthy condition of the transmitter itself. What is span and zero adjuster? Everywhere it is written over there that, see, this is the span adjuster and zero adjustment. Zero and span adjustment means the the device ranges from 1 to 5 kg per centimeter square. So suppose. So this span can be changed as say 2 to 6. It was 1 to 5 initially. For span adjustment, using span adjustment, if we shift the pivot position somewhere within this beam, then the gap will be more or less accordingly. So the range can be varied. And zero adjustment means say zero elevation or zero suppression. Using this screw, this gap of flapper nozzle can be adjusted so that the zero of this device, of this transmitter, can be shifted. Say the range is 0.5 to 3, say. Again, this 0.5 is treated as the 0. Then say this is 0.5 treated as 0. So 0.5 kg per centimeter square to certain range. You may use this from 0 to say 3.5, or maybe minus 0.5 to 4, like that. So this 0 value can be changed. So zero elevation, or this is called zero elevation or zero suppression, by adjusting this screw and the gap, using the screw of this gap. So this is the real smart transmitter, where this is again a DP cell filled with silicon oil. Silicon oil, this is the performance is like a capacitive type. So silicon oil is filled. Just notice, this is the say this is the high pressure side, this is low pressure side. So the process fluid is connected through this, and this is the there is a diaphragm, and this is the low pressure side diaphragm. At the middle of this there is another diaphragm, and these are the glass blocks. It is labeled as glass block. So this glass block separates, and these diaphragms are metallic diaphragm, generally made of gold, in order to produce the capacitive effect. And these are connected to the to this Wheatstone bridge. These are the balance arm, and these two arms are connected with this low pressure side and high pressure side. So when pressure changes at the high pressure side over low pressure side, then the capacitance at this end will change compared to the other side. So this unbalanced signal will transmit through the electronic amplifying unit, just like electronic block diagram. There is a pre-amplifier, then amplifier, signal conditioning unit, analog to digital converter, then microprocessor for programmable feature, then D2A converter, and the output signal will out from here. And there is another sensing unit that is called the secondary sensor. This is the temperature sensor. That means this is incompressible for a wide range of temperature. Silicon oil is the viscosity is constant. Viscosity remains constant for wide range of temperature, but the temperature condition, that means the healthy condition of the transmitter unit, itself can be monitored. There is a thermocouple sensor, and that is again transmitted through the preamplifier signal conditioner A2D and to the microprocessor. And there must be a data table, that is the variation of temperature versus the fluid condition. So from the memory, the microprocessor can monitor or check the healthy conditions of this device. That is the use of secondary sensor in order to check the diagnostic or status checking. That's all about transmitter system. So we have electronic transmitter, electrical type transmitter, pneumatic transmitter. Nowadays mostly transmitters are smart transmitter. And why this it is called smart? So smart features and intelligent features, since the span adjustment and zero adjustment for a pneumatic system, all these are this requires human intervention in order to adjust the span's position, screw position, and the zero elevation or zero separation screw position should be changed manually. But for smart transmitter, since this is programmable, so this can be done through programming automatically. So these are the intelligent features, that adjustment of span and zero can be done through program, and adjustment of damping time constant or response time. And the major is important point is diagnostic check or status check of the smart transmitter. Thank you.